Emergency systems do not operate very often or for long, but when they need to work, they need to work. Fuel systems are designed with redundancy and the ability to detect a failure and compensate for it. The issue is mechanical at heart, but it also drives the complexity of controls. Let's look at some of the principles.
Redundancy of system components is the key to designing against system failure. Good design will require a determination of which elements could fail and how the system will detect and compensate for this failure. Tanks and piping are primarily subject to failure from fuel leaks, which are by the leak detection monitor. For underground tanks and piping, there is the additional potential for a perceived leak, a monitoring failure or false alarm that could, for regulatory reasons, require a shutdown of the problem tank or pipe. For this reason, it's important to have dual tanks and piping systems for underground installations. Pumps can fail from lack of prime, internal failure, or electrical problems. They can also fail from setup issues like closed isolation valves or controls not in auto. Current, flow, or pressure sensors are used to monitor pump operation, and failure causes the operation to switch to a redundant pump. Valves fail from electrical problems or leakage past damaged sealing surfaces. Electrical problems will result in a lack of flow or a tank low-level condition. Leakage past valve seats will result in a tank high-level condition. So valve problems are often detected indirectly through level sensors. Another major valve failure issue is in valve position errors in multi-tank systems that create inadvertent fuel transfers and potential overflow conditions. Valve positions are monitored with limit switches, and the controller checks the positions versus the permissible conditions in the programming. Day tank inlet valves should have a redundant valve arrangement, and tank selection valves should allow for switching operation to the redundant supply tank. In addition, all control valves should have a manual bypass mechanism. Where sensor failures are designed to shut down parts of the system, you should have redundant sensors, both of which must be activated to create the shutdown. In other circumstances, the sensor may have built-in secondary sensors. For example, a tank high-level sensor typically has high warning at 85% and high alarm at 90%. Underground piping systems are subject to failure, which may cause them to be out of service for days or weeks. We recommend that underground piping be provided with redundancy. Above-ground piping, particularly with welded connections, is often provided as a non-redundant element. However, with a higher-level critical design, parallel redundant piping systems are used. It is important to have a simple fallback mode of operation for the fuel system in the event of a control failure. This typically means two things. First, all actuated valves should have a manual open bypass mechanism either built in or as a parallel path. Second, pump motor starters should operate in the manual mode on line power without control power. These items allow the operations personnel to turn on pumps in manual mode and operate manual valves to provide fuel to the generators through a power outage.